Welcome back, dear children. Now we will move to the next topic, that is power. Okay, our next topic is power. Rate of doing work can be called as power. That is, how much work is done on a given time. That can be considered as power. So the equation is power is equal to work by time. Okay, rate of doing work is power. So an example, we are considering a cycle race. Let the person A completed the race with 3 minutes. Okay, person A completed the race with 3 minutes. Person B completed it with 1 minute and person C completed the race with 2 minutes. Then who is the winner here? Naturally, the winner will be the person who completed within 1 minute, isn't it? So, all these 3 persons have done the same work. 3 have completed the distance, but who was having more power there? Person B, isn't it? Why? Because he completed the race within the short period of time. So that is power. That means the person B has more power. Okay. So did you understand what is power? Power is rate of doing work. That is how much work can be done in the given time. So even though all are completing the same work, the person who completes the work within a short period of time will be having more power. Okay. Now, about the unit, what is the SI unit for work? It is joule. Work or energy is given in joule. Then, time it is second. And this joule per second is watt. Okay. It's the name of a scientist. So, when we write the simple, we have to use capital letter. When you are writing the whole name, then you have to use small letter. So is it clear about power? So power is the rate of doing work. Its SI unit is joule per second or watt. Okay. Power actually says how fast the energy gets converted. Okay. Power actually says how fast the energy gets converted. When you are buying a machine, we can see the power rating of the machine written on it. Isn't it? Have you noticed? So in most of the electronic equipments, we can see the power rating. Electrical equipments, we can see the power rating written there. So actually what does this power rating says? The rate at which work is done on an object by this machine. Okay. Power rating tells us the rate at which work can be done on an object. Now, when you are considering SI unit for power, it is watt. For machines and all, we need the bigger units of power. So, it can be kilowatt. Kilowatt means it will be 10 raised to 3 watt. Kilo means always 10 raised to 3. Then, megawatt. Power can also be measured in megawatt. That is 10 raised to 6 watt. And when you are considering the pump set, that is motor and all, their power should be more. In that case, usually power will be given in horsepower, HP. So there you can see HP. HP stands for horsepower. 1 horsepower is 746 watt. Okay. So these are the bigger units of power. Even though SI unit is watt, when you are considering machines, the power of the machines will be more. So we'll be using kilowatt, then megawatt or horsepower. Okay. Now, when you buy a bulb, when you go to buy a bulb, what will you say? Will you go and simply say to give a bulb? Normally, we will say the power we need, isn't it? So it can be either a 9 watt bulb. Earlier, when we were using the incandescent bulbs, filament bulbs, it was of 100 watt. But since now we are using LED, CFL, etc., we'll go for 9 watt or 20 watt bulb, isn't it? So do you know what does this 9 watt or 20 watt stands for? It is the power of that bulb. So if you are buying a bulb of 9 watt or 25 watt, it means that bulb will convert 25 joules of electrical energy into light energy in 1 second. Okay. So I'll repeat. I'll tell you how it comes. You are buying a bulb of power 25 watt. Okay. Power is work by time, or instead of work you can use energy also, because work and energy have same dimensions. Okay. So if a bulb, power rating of a bulb is given as 25 watt, it means that 25 joules of energy. What energy is given to a bulb? Electrical energy, isn't it? So 25 joules of electrical energy gets converted to light energy in 1 second if the power is 25 watt. Then for a heater, if the power rating is given as 25,000 watt, okay, then, or 2,500, don't go for 25,000, 2,500 watt, then what does it do? If the power rating of a heater is given as 2,500 watt, then what can you say? It converts 2,500 joules of electrical energy into heat energy. Okay. So is it clear about the power rating? So with the power rating, actually power rating will say how much or at what rate this will do work. Okay. The rate at which work is done by this machine or equipment on another object. That is what we will get from power rating. Then if you are considering a 60 watt bulb and a 25 watt bulb, which one will give more light? Naturally, it will be the 60 watt bulb. Why? A 60 watt bulb will convert 60 joules of electrical energy to light energy in 1 second, whereas a 25 watt bulb can convert only 25 joules of electrical energy to light energy in 1 second. So more conversion is done in the case of a 60 watt bulb, isn't it? That is why 60 watt bulb will give you more light than a 25 watt bulb. Okay. Now, the next thing, suppose a bulb of 100 watt. Okay. For incandescent bulbs, we are using this 100 watt. Now, for LEDs or CFL, we don't want 100 watt. Okay. So we are considering an incandescent bulb. I have used the same example given in your textbook. So let a 100 watt bulb works for 1 hour. Okay. So how much energy is consumed there? How will you calculate this? A bulb of 100 watt works for 1 hour. So how much energy is consumed? Our equation is power is equal to work or energy by time. That means work or energy will be power into time. Instead of work, you can use energy. Okay. So energy will be power into time. So energy is equal to how much electrical energy will be consumed by a 100 watt bulb when it works for 1 hour. So electrical energy or energy consumed is equal to power into time. 100 into time is given in hour. Okay. If power is given in watt and time is given in hour, then we can write the energy in watt hour. Okay. Watt hour is a unit for electrical energy. Watt hour. If the power is given in watts and time is given in hours, you can say electrical energy in watt hour. Then in normal case, what we will do, we need it in SI system. What is the SI unit for energy? It is joule. So if you want to get energy in joule, power should be in watt and time should be in second. So in that case, what we will do? Power is already given in watt. Now, how to convert hour into second? 1 hour means 60 minutes and 1 minute is 60 seconds. So 60 into 60, 3600. So 360,000 joules of energy will be consumed. So is it clear? Once again, it's just an example given here. You are considering a bulb of 100 watt which works for 1 hour. So how much electrical energy is there? So energy is given by power into time. If I am taking power in watt and time in hour, I'll get the answer in watt hour. If I need it in joule, I should convert hour into second. Okay. So in watt hour, it will be 100 watt hour, and if it is in joules, it will be 360,000 joule. So is it clear? With that, we completed the chapter. Okay. So what all things did we learn here? We started with power. What is power? Power is the rate of doing work, isn't it? That is, work by time is power. Then what did we learn about the unit? SI unit is watt. Power rating. Power means, actually it says how fast the energy gets converted. Power rating gives the rate at which work is done on an object. Bigger units of power are kilowatt, 10 raised to 3 watts. Then megawatt, 10 raised to 6 watt, and horsepower. 1 HP equal to 746 watt. Then we have considered about 1 or 2 electrical equipments. So if the power rating of a bulb is given as 25 watt, it means 25 joules of electrical energy gets converted to light energy in 1 second. Then after that, I told you how to calculate the electrical energy consumed using the equation power into time. If power is in watt and time is in hour, you will get the answer in, or energy in watt hour. If you need it in SI system, power should be in watt and time should be in seconds. Okay. Now I'll tell you about the homework questions. Page number 66. You can take page number 66. Give reasons, question number 6. Then short answer questions, question number 8. Long answer questions, question number 7. So these are the 3 homework questions. List the differences between energy and power. Already we learned about the entire thing, and it is given in as a box here. You can just select any 4 differences and you can write that. Okay. No need to consider the entire thing. So just write any 4 differences. List the differences between energy and power. Okay. Now we have to do 3 numericals, isn't it? We stopped with question number 7 and now we will move to question number 8. A machine does 392 joule of work. So what is given here? Work is given as 392 joule of work in 4 seconds. So time is given as 4 seconds. What is the power of the machine? So a direct question, isn't it? What is the equation to calculate power? Power is equal to work by time. Work is 392, time is 4. So how much will be our answer? 392 divided by 4. So should I do the division directly? 392 divided by 4. Here, how much should I take? 9, isn't it? 27, 36, 3, 32, it will be 8. So our answer is 98 watt. Okay. So it's a direct question. Work and time were given. We were asked to calculate the power. Power is equal to work by time. Now, we will move to question number 9. Calculate the time taken by a 25 watt bulb to transform 3000 joule of energy. So in this case, we were asked to calculate the time. So, what all things are given here? Power is given as 25 watt. Then, work or energy is given as 3000 joule. So, here we have to calculate the time. Power is equal to work by time, or work is equal, time. We have to calculate time, isn't it? So, time is equal to, T will go here and power will come down. W by T. So, this is 3000 divided by 25. Now, in 125 will go 4 times. Since it is 300, 4, 8, 12. 1 0 is there. So, the answer will be 120. Power and watt are given in SI unit. So, naturally, time also will be in SI unit. So, it is equal to 120 seconds. Okay. Now, we will move to the last question. An electric kettle of power 2 kilowatt is used for 1 minute. Find the energy supplied by the kettle. Okay. So, here power is given as 2 kilowatt. In order to convert it into SI system, we need it in watt, isn't it? So, how to convert kilowatt to watt? It is multiplying by 1000. So, this will be 2000 watt. Then, it is used for 1 minute. Time is given as 1 minute. So, we need it in SI system. That means in seconds. So, this is equal to 60 seconds. Then, find the energy supplied by the kettle. We have the equation power is equal to work or energy by time. So, energy will be power into time. So, 2000 into time is 60. 6 into 2, 12. Then we are having how many zeros? 4 zeros are there, isn't it? So, this is 120,000. Unit is joule. Okay. So, is it clear here? Since the time is given in minute, you have to convert it into second. So, with this, we completed the chapter. Okay. You can just go through the picture study. Okay. So, from in the last video, I told no need to write the lecture note, but for this video you have to write the lecture note. Then do the homework questions, do these numericals before the Google Meet. Okay, so thank you children.